We're going to start by going over the Quiz 2 solutions today from our MCTC Applied Algebra class. Learning Target 1D is all about applying and justifying your use of logarithms. And we start out with number 1 with a simplifying problem. You can see the logarithmic expression here. I'll admit there's not very many steps to show for this one. You can actually type it directly into your graphing calculator if you use the log base button, and you should get the answer of 2. That's worth 2 points there for getting that correct answer. I've also copied and pasted the change of base formula here on the right from our textbook. If you're using a calculator other than the graphing calculator, you might not have a log base option. So you would have to use the change of base formula to rewrite this expression. And I can use that same example to rewrite my expression log base 749 would be equivalent to the ln, the natural log of 49, divided by the natural log of 7. That's just another way to type it into the calculator. If you're using like a phone calculator or the Google Scientific Calculator, then that's going to be the best way to find your answer there. Either way, same answer. Value of 2. For number 2, which of the following equations can be simplified using logarithms? Well, you have to remember that logarithms are used to solve for exponents. And there's only one exponential function here. And that would have to be choice B. It's the only one where your variable is in the exponent position. Now we're going to explain this choice by actually solving this equation using logarithmics. And I've copied and pasted an example here from the textbook on page 36. I can use that same idea to rewrite my expression in log form. This would be log base 5 because of my base being 5. Now here we're putting our solution 300, and a logarithm is going to tell us the value of the exponent. And in this case we don't know the exponent, so we put a variable there. But now that I have it in log form, we can go ahead and type everything on the left here in the calculator to get a solution, a simplified answer. Again, you can type that in using the log base in a graphing calculator, or you can use the change of base formula. The natural log of 300 divided by the natural log of 5. In my calculator, that gives me 3.5439, and I'm going to round to the nearest 10,000th place. So we get our final solution. 10,000th place is 4 decimals. And since the last decimal is a 9, that's going to round my 10,000th place up to a 4. That means the value of x that goes and that solves that equation in number 2 would be 3.5440. The last one here, number 3, is a simplifying problem. We have a little bit of simplifying inside of the parentheses first. Remember, those explicit groups always happen first. So let's simplify the first explicit group here. 15 divided by 4 inside of the parentheses would happen first. And I get 3.75, so I'm going to rewrite it as ln of natural log of 3.75 times, here we haven't dealt with this part yet, so I'll just copy it how it is. This is also an explicit group, because it's in the parentheses. So let's go ahead and do our exponent next. To the power of -1, I want to make sure to use a negative there. And I get 8.33, so we will oops, I need my pen. We will substitute that value in. The natural log of 3 75/100 times 8.3 repeating. Again, we'll use 4 decimal places when we have to round. Now the natural log actually is an operation, so I need to do the natural log of 3.75 now. I'll type that into my calculator. There is a button for the natural log. Shoo! Excuse me. And I get 1.3218. Again, I had to round slightly. And now that we've simplified the natural log, we can do the last step, which is to multiply. My answer is 11 point. We're not dealing with great numbers here. But when I round to 4 decimal places, that would be my final answer of 11. There is one more learning target, which was 1E. That is solving problems using simple and continuously compounding interest. This is the one where we have all the financial formulas. In each problem, they're going to give you exactly which formula to use, and we are plugging in or substituting the variables to simplify. So on number 4, we're using the simple interest formula here that's given. And we need to define each of our variables. We're going to find the amount in an account if $7,000 is invested to start. So our principal is $7,000. The annual interest rate is 3.7%. We need to turn that into a decimal to get our rate, and to turn anything into a decimal, you divide by 100. So there's my rate. The time that we need is 20 years. And that should be everything we need in order to simplify our equation. Now let's plug in area equals, not area, future amount, A, equals 7,000, parentheses, 1 plus the R value times T, so times 20. Give me a little dot there. And now we can simplify. Everything in the parentheses needs to happen first, starting with the multiplication. So 0.037 times 20 plus 1. We'll simplify this to 7,000 times 1.74. And then the very last step is to multiply these two things. I'll have to write it down here. 7,000 times 1 74/100 is 12,180. So in 20 years, with an annual interest rate of 3.7%, my $7,000 that I started with will become $12,000. Number 5, we've got a different formula here to use. This is the present value formula. It's when we're trying to find the starting amount. How much do we need to set aside today to have $500,000? So our future amount, we want $500,000 in 30 years. The time is 30 at a 7% interest rate. And I turn that into a decimal. Here we have the natural number E. Remember, it's not a variable. It is a number. And we can find that number on the calculator. So 500,000 times E, the natural number, to the negative 0.07 times 30. You would have to solve the exponent first. And there is a button just for E on our calculators. It's on the same key as the ln, if you hit second there. So I type this in carefully, making sure to type it exactly how I see it. This simplifies to 500,000 times 0.1225. And I made sure to do the exponent before I multiply here. My last step will be to multiply. Which gives me my starting amount. My principal is 61,228 with 21 cents. This one I'm going to decide to round to 2 decimals because it's money. And my final answer, in terms of money, would only have 2 decimals. So that would be the amount I need to start with, or I need to invest to have $500,000 in 30 years. All right, 2 more that we need to go through. The next one is using our interest rate formula here. To find the interest rate we would need if we wanted $1,000 to become $15,000. So our starting amount is $1,000. Our future amount is $15,000. And the years says 20 years. So notice the equation changes a little bit, but we're still using the same variables. We're plugging in now. To find the interest rate, we'll take the natural log of the future amount, 15,000, divided by the starting amount over t. And I want to make sure to simplify what's in the parentheses first. So 15,000 divided by 1,000 is 15. I need to take the natural log of 15, and then I can divide by 20. So ln 15 first, I hit enter before dividing by 20. And I get an R value of 0.1354. And in terms of percent, that is a 13.54% annual interest rate. Don't forget to turn it back into a percent there at the end. One more, we're going to use our time formula now to calculate the length of time it will take for $10 to become $100,000. I would expect that this would be a long time because that is a great investment. Our annual rate is 7.25%. That's the same as 7.25%. And if I turn that into a decimal, I get 0.0725. And we're ready to use our formula. So we get that the time equals the natural log of the future amount divided by the starting amount times the interest rate with an exponent of, and I'm going to substitute my value in there, with an exponent of -1. I'm going to make sure to do what's in the parentheses first. 100,000 divided by 10 is 10,000. Then I can do the exponent and the natural log. Both of those need to be done before we multiply. You get 13.7931. Again, you're not going to be dealing with perfect numbers when you're doing these financial formulas. So I'm constantly rounding. In the meantime, I'm going to round with 4 decimals, but my final answer, I will round depending on the context. Now I need to take the natural log, so the ln of 10,000 And that gives me 9.2103. And then I can finally multiply to finish. Multiply these two numbers together to get my final answer. $127.1. And if we're talking years, 127 years it will take for my $10 to become $100,000. All right. Thanks for watching.